Venus, our closest planetary neighbor, shimmers like a celestial diamond in the evening sky. Its brilliance captivated ancient astronomers, inspiring tales of love and beauty. But beneath this alluring facade lies a world of scorching heat and crushing pressure. Venus is a planet of extremes, a stark reminder of the diverse and often hostile environments that exist within our solar system. The surface temperature of Venus is a staggering 462 degrees Celsius, hot enough to melt lead. This extreme heat, coupled with a dense, toxic atmosphere, makes Venus one of the most inhospitable places in our solar system. Despite its proximity to Earth, Venus remains shrouded in mystery, its surface hidden beneath a thick blanket of clouds. Only in recent decades, with the advent of advanced spacecraft and telescopes, have we begun to pierce the veil of Venus and unravel its secrets. Many people assume that Mercury, being the closest planet to the Sun, must be the hottest. However, Venus holds that distinction. This seeming paradox is explained by a phenomenon known as the greenhouse effect. While both planets receive intense solar radiation, Venus's dense atmosphere traps heat far more effectively than Mercury's thin atmosphere. Sunlight penetrates Venus's atmosphere and reaches the surface, warming the planet. The surface then radiates this heat back outwards. On Mercury, this heat escapes back into space. But on Venus, the dense atmosphere, composed primarily of carbon dioxide, acts like a giant blanket, trapping the heat and raising the planet's temperature to extraordinary levels. This runaway greenhouse effect has resulted in a surface temperature that remains relatively constant, regardless of location or time of day. Venus is a furnace, a world where temperatures soar high enough to melt lead day and night. The atmosphere of Venus is not only incredibly hot, but also incredibly dense and toxic. Composed primarily of carbon dioxide, with nitrogen as a minor constituent, the atmospheric pressure at the surface is 92 times that of Earth's. This intense pressure is equivalent to being 900 meters beneath the ocean surface. The thick clouds that blanket Venus are not composed of water vapor, like Earth's clouds, but rather sulfuric acid. These clouds reflect sunlight back into space, contributing to Venus's brilliant appearance, but also trapping heat within the atmosphere. The sulfuric acid rain that falls from these clouds never reaches the surface, instead evaporating long before it lands due to the extreme heat. The combination of intense heat, crushing pressure, and a toxic atmosphere makes Venus a hostile and unforgiving environment, a stark contrast to the relatively temperate and life-sustaining atmosphere of our own planet. Earth and Venus. A study in contrasts. Despite their similar size and proximity to the Sun, Earth and Venus are worlds apart in terms of their environments. Earth is a vibrant planet teeming with life, while Venus is a scorching inferno, its surface devoid of any known life forms. This stark contrast highlights the delicate balance of factors that contribute to a planet's habitability. While Earth's atmosphere is primarily composed of nitrogen and oxygen, Venus's is dominated by carbon dioxide, a potent greenhouse gas. This difference in atmospheric composition is the primary reason for the vastly different temperatures on the two planets. Earth's oceans and vegetation absorb carbon dioxide from the atmosphere, regulating our planet's temperature. Venus, on the other hand, has no such mechanisms to moderate its climate. The extreme conditions on Venus serve as a stark reminder of the importance of understanding and protecting our own planet's delicate environment. Unveiling the mysteries of Venus. Despite its harsh environment, Venus remains a subject of intense scientific interest. Scientists are eager to understand how a planet so similar to Earth could evolve so differently. Exploring Venus provides insights into planetary climates and atmospheric evolution. Several missions to Venus are planned using advanced radar and imaging technologies. These missions will map the planet's surface in greater detail, study its atmosphere, weather patterns, and volcanic activity. By studying Venus, we understand the processes shaping our planet and the conditions necessary for life to arise. Venus holds many secrets waiting to be unlocked. Venturing into this extreme environment expands our knowledge of planetary science and deepens our appreciation for our own planet. The importance of exploring extremes. Exploring extreme environments like Venus is not just scientific curiosity. It pushes the boundaries of knowledge and explores the unknown. Studying hostile places helps us understand life's limits and conditions. It leads to technological advancements benefiting humanity. Designing spacecraft for Venus drives innovation in materials science and engineering. These advancements improve our everyday lives. Exploring the cosmos, we encounter more extreme environments. Embracing these challenges expands our understanding of the universe. The pursuit of knowledge drives us forward for generations to come.